Hello everyone, we're going to just practice two more examples. The first example here is a lot like what the first lesson was over, so nothing has really changed other than just giving you another trig function to practice. So go ahead and pause the video, graph y equals 2 plus cosine x. We're going to revolve this region that's bounded by y equals 2 plus cosine x in the x-axis from 0 to 2 pi about the x-axis. Go ahead and pause the video, graph this for right now, reflect it over the x-axis, and then see if you could come up with the area of each slice, the formula for that, or the expression rather, and then the expression for what we're going to need to find the volume, so the integral as well. All right, so when graphing y equals 2 plus cosine x, it's just the graph of y equals cosine x shifted up 2 units. So we're going to start normally at where x equals 0, y would equal 1. So we're going to have to go up to 3. And then at pi over 2, cosine would be 0, so we would just go up to 2. Cosine of pi is actually -1, so going up 2, we would be at 1. Cosine of 3 pi over 2 is 0, so we would be back up to 2. Then cosine of 2 pi is 1, so we're going back up to 3. So we're looking at this curve here. We just need to reflect it over the x-axis, so it would be at -3 here, -2, -1, -2, and then -3. We have something that looks like this. So as soon as we start to shade this region here, again from 0 to 2 pi, this is what we're going to be reflecting. So then it captures the shaded region on the other side, and then this is where we go to draw our circular slices. And just enough throughout to get a good idea of what this solid is going to look like. All right, so again, each slice is a circle. The area, again, pi r squared. Here, each radius, again, is going up to the y value here. So it's going to be this quantity 2 plus cosine x squared. So this becomes pi times the quantity 2 plus cosine x squared. So then our volume, we again could keep the pi out in front. It's going to be the integral from 0 to 2 pi. And then 2 plus cosine x squared dx. Or you could go from 0 to pi and just double it. But at 0 to 2 pi, we're still working with 0. It's not much more work that way. Or we can just go from 0 to pi of 2 plus cosine x squared dx. Now for your homework, I still want you to go through evaluating the integral by hand. For this one, go ahead and evaluate on CAS. So go ahead and pause the video, type that in, and we'll see what you're coming up with. And hopefully you were getting that our volume is 9 pi square cubic units. All right, so just some extra practice with trying another one of these. All right, now this next one is going to sound very similar. We want to find the volume generated by rotating about the x-axis, the region only in the first quadrant, bounded by the graphs of y equals x cubed plus 1 and y equals x plus 1. So right now, be very careful as you go to sketch both of these in the first quadrant. Figure out the points of intersection as well, and just sort of shade in this region right now. So pause the video and go ahead and try that. So when we're looking at x cubed plus 1, if we were at 0, we're just shifting that up 1, and then 1 cubed plus 1 will give us 2. But we have to be careful. It's not going to be a straight line. It's going to be a curve a little bit, because remember what the graph of y equals x cubed looks like. Looks something like this. So if we were to again go with a -1, we would be at a 0. So it's starting like over here, but we tend to go up, so it looks a little bit like this. So it's concave up. And then y equals x plus 1 is just going to be a line. So they intersect when x is 0 and when x is 1. But I just want to draw this here as well. So this is a little slice that we're looking at. And this little shaded region right here is what we're going to revolve. So notice now the shaded regions don't go all the way down to the x-axis. So I'm going to copy this down here as well. So again, our curve is going to look something like this. I'm going to draw the line as well. And we get this little shaded region right here. So as this goes to rotate, the middle is open, and we call this a washer. So each slice is not a circular, a solid circle anymore. It's what we call a washer. And washers, just like with tools, screws, nuts, bolts, everything like that, it just looks like the middle part is cut out. So that's what a washer is, and that's what we're looking at here. So we have a little bit of extra work involved with this type of problem. All right, so as we start to revolve this again, it's the middle part. We could technically draw a little circle inside too. Just makes it harder the more we kind of sketch on here, but this is what is occurring as we go through this. All right, so the way we're going to look at this is that the area is equal to the area of the larger circle, and we're going to be subtracting the area of the inner circle. So the total area of the washer is going to be, we'll say area of outside minus the area of inside. Same thing with the volume here. We're going to have the volume overall is the volume of the outside minus the volume of the inside. So we have to figure out the radius here. All right, I'm just going to start with the middle one. So the radius, we have two of them. We have the radius of the outside. So I'm going to go all the way up to the top here. So the outside radius is going to be the y value for the x plus 1. So I'm going to say the area of the outside is going to be pi times the radius squared, where in this case it's pi times the quantity x plus 1 squared. And then the area of the inside goes up to the other curve. Let me use green on this one. So it goes up to the curve I have drawn in blue here, which is the x cubed plus 1. So here the area of the inside is going to be pi times the quantity x cubed plus 1 squared. So then our total volume is going to be the volume of the outside minus the volume of the inside. That's how we'll get the volume of everything that's in between those two. All right, so when we go to write this, again, we could keep the pi out in front. For both of these, we're still just going from 0 to 1. So it's going to be the integral 0 to 1 of the x plus 1 squared dx, and then minus pi again times the integral of 0 to 1 x cubed plus 1 squared dx. Because the limits of integration are the same, we can just write this as pi times the integral 0 to 1. Keep in mind here, an a squared, I'm going to write it this way. A squared minus b squared is not the same as a minus b squared. So I still have to keep this as the quantity x plus 1 squared minus the quantity x cubed plus 1 squared dx. Now what we can do, we are going to go through this by hand and just expand both of these. So we get pi times the integral 0 to 1. This will become x squared plus 2x plus 1 minus the quantity. We'll get x to the 6th plus 2x cubed plus 1. We don't need a square anymore. And then dx. Carefully subtract. So we don't really have any like terms. I'm just going to write this in order here. So we're going to get a negative x to the 6th minus a 2x cubed. Our 1's are definitely going to cancel out. So then we'll get a plus x squared plus 2x, and then we'll take the antiderivative here. All right, so we're going to get a negative x to the 7th over 7 minus just 3x. I don't know what I was thinking there. Minus a 2x to the 4th over 4. That will simplify in the next step, plus x cubed over 3 plus x squared. We could evaluate at this step, so we're going to get a negative 1/7. This will just turn into x to the 4th over 2, so this just becomes a minus a 1/2 plus a 1 cubed plus 1, and then technically minus 0. We can get everything over common denominators next. Looks like we're just stuck with 42 here, so we could say negative 6 40-seconds minus 21 40-seconds plus 14 40-seconds, and then plus 42 40-seconds. And combining all of those, we should end up with 29 pi over 42. Again, cubic units. All right, so now some of our problems may become a washer. So you just have to very carefully take a look at when it's a little slice like this. It's the longer radius here that's going to go to the top. So kind of like with the area, remember how we did the top minus the bottom? That's essentially what we're doing here. So it's the top curve minus the bottom curve to get that area, and then we take the volume of that. All right, so later on in future lessons here, there's going to be a different way called a shell method. So we have a disk method, which is what we've been looking at. The very last lesson is going to be something called the shell method. But then we also have to look at a lesson where we don't find volume of something that is formed by revolving an area that's bounded by some regions here or by some curves. We'll have to take a look at almost like cross sections if something is coming up through sort of a two-dimensional space, but that'll be a lesson for another day. All right, guys, so what you're going to do is off of gift 7-3, so I already have that scanned in for you. Just do 5 and 8. Please make sure you make a sketch of the graph, set up the areas, and then the integral as well, and make sure you evaluate the integrals by hand.